research I'm doing right now is on microplastics and trophic level transfer. We're looking at microplastics and how they transfer from Daphnia magna to ghost shrimp.
So we're both actually studying the New Zealand mud snail. It's an invasive species in Michigan that has just started to invade the rivers and streams. And so I look at the individual and population growth rates of the New Zealand mud snail.
So I'm also doing same work as Emily. I'm just specifically looking at grazing and non-grazing interactions with the New Zealand mud snail.
Yo trabajo con caudales ambientales o caudales ecológicos y yo estoy tratando de identificar a través de un experimento cuál es el límite máximo que puede soportar un río antes de que pierda sus cualidades. Entonces reduzco el caudal y después le regreso al sistema para ver si es que hay una respuesta que yo pueda cuantificar para los operadores del agua.
So I do environmental DNA for an endangered species of dragonfly. I don't do metabar coding. We focus on primarily species-specific environmental DNA, which is a little bit different than most. It's really interesting. So we've pretty much moved past the presence-absence place that most people are at for environmental DNA, and I focus mostly on persistence and accumulation within a stream, and then also in mesocosms. And so looking at how things like temperature and seasonal variability in behavior of my species affect environmental DNA accumulation and persistence.
Yeah, I've done some like remote sensing image, like looking at the accuracy of Landsat images, compared that to Google Earth in Volta Basin in West Africa, just looking at Ghana and Burkina Faso. So for my interest was just look at like what has been like those small reservoirs in Volta Basin has changed over time from 2000 to now.
So right now I'm looking at phosphorus cycling in Milford Lake in Kansas, where it often has cyanobacterial blooms, and we're looking at the phosphorus cycling in the water and the sediment and the interactions going on there.
Well, I'm an undergrad, so I feel like I'm really new to all of this. I mean, I feel like I came here to learn more about freshwater science, and honestly, all of the work that people are doing is just so amazing and so admirable, like inspiring, and I hope to learn from it and hopefully come up with a research project idea for my senior thesis.
Sure, I study the effects of dynamo, which is a nuisance algae, and its effects on the food web and how it impacts fish growth.
So I study plastic pollution in urban streams, and I look at naturally occurring debris dams, which are just areas along the stream that collect a lot of organic material and woody material. And we know that they're hotspots for a lot of garbage, especially plastic. And I study how they interact with different organisms that live in the rivers and affect important ecological processes such as leaf litter breakdown.
Entonces ahora estoy trabajando con calidad de agua, sí, un poco con el impacto de la escorrentía de nutrientes en la calidad del agua, y particularmente estoy intentando desarrollar métodos para cuantificar el agua subterránea y los niveles de nutrientes en el agua subterránea y cuánto el agua subterránea aporta a los balances de fósforo y de nitrógeno en lagos.
I'm using satellite images to construct a history of algal blooms on Utah Lake.
So I study bacteria and fungi on dead leaves and streams, and that doesn't sound important, especially to my family. But what's really important is we have these tree plantings that people do for restoring stream banks, and restoration managers will focus on just planting a diverse array of trees along these banks just for biodiversity's sake. But these trees are made of different chemicals, and depending on what they're made up of, they can either decompose really quickly in the river, or they can take a long time to break down the river. So this is important because this bacteria and fungi will colonize on these leaves and affect how their elements are transferring up the food web. And it's also important because leaves are the base of the food web. And so we have aquatic insects in the streams who are consuming these leaves. And so if restoration managers don't understand that there's more to just planting a diverse array of trees along the streams, they could be essentially affecting the whole stream food web.
So for my PhD dissertation research, I'm really interested in how landscape scale influences, like the amount of roads near streams or the percent of forest in a watershed, might affect freshwater fish biodiversity, which means the number of different species in a given area. And I'm also interested in how those things might affect fish distribution. So can we think about how human activities on the landscape might affect where brook trout are not, and where they are? And so that's part of it. And then the other part, I'm actually interested in science communication. And so I'm interested in how we as scientists talk about our science and our work to folks who aren't scientists, and trying to package that in ways that are accessible and applicable and trustworthy and relevant to general folks. And so I've got a project called Southern Stream Fish. There's a website, www.southernstreamfish.com, that kind of outlines what it is I hope to do. And yeah, that's my research in a nutshell.
Yeah, so it's kind of ironic that I'm also working on drinking water right now. So I'm working on something called the PPCPs, or aka pharmaceutical and personal care products. So these are like compounds which are found in like your shampoo, your sunscreens, your perfumes, and from the different antibiotics that people use. So they do not use it properly, they kind of flush it down, and they end up in the wastewater treatment plants. So these wastewater get processed, and they finally again like move into the reservoirs, which again goes into the drinking water. So I want to take a look and see how drinking water and wastewater also treatment plants have PPCPs, what kind of concentrations they're found in these treatment plants, and if the tap water also has the same amount of PPCP concentrations, and if there is like any way by which we can mitigate that, like do something about it.